Hello, here we are. Okay, so let's see, where did we leave off? I think we are ready for chapter 3, as a matter of fact. So let me get that open. All right. Oh, okay. Yes, this is a fairly complicated chapter. Let me just go back and quickly review what we did last time in chapter 2. We finished up the appendix with the graphs, and then we went ahead, and this chapter was more or less about introducing the field of economics, a lot of key concepts that we'll be looking at throughout the course, and the types of resources, the types of returns to these resources, entrepreneurship, income distribution. So basically, it was almost like a buffet of topics that we'll be looking at in more detail throughout the course. Okay, so it was almost like meant to be an introduction to what macroeconomics is all about. Okay, then we had the circular flow model, which it isn't terribly important. It's just a quick way of looking at how the different sectors of the economy interact with each other, but we're not going to ask you to memorize it or anything along those lines. It's just an idea of, it's like a roadmap to see how the economy is organized. That's really all that it is. It's a fairly simple look at it, but it does give you a sense of how the different sectors are, in fact, all interacting with each other at all times, how the incomes of one sector are the expenditures of the other and vice versa, that type of thing. Anyway, so now we're ready. Now, chapter 3, we're starting to look at a fairly complicated topic. That topic is opportunity costs, basically, but we're going to introduce a graph that enables us to understand what these opportunity costs are all about. So this is our first serious hardcore graph of the course. It's called the Production Possibilities Frontier. Sometimes it's called the Production Possibilities Curve. It means the same thing. So if you may have run into this in a micro class, you may have heard it given a slightly different name, but it is the same thing. And so, oh, hold on a second. I just realized I've forgotten something. I'll be right back. All right. Okay, here we are. So this is the Production Possibilities Frontier. Now, basically what this is all about is that it's an attempt to show us how much of two different goods we can produce with the same resources. Okay, so let me show you a picture of what this thing looks like. Now, for this one, I've chosen as an example Starbucks. Now, everybody here is familiar with Starbucks. So let's just say that most of those drinks are very similar to each other. They're not that much different. They all start with coffee beans. Some of them have milk in them, some of them don't. You can obviously add the sugar and the spices and the syrup and all the rest, but for all practical purposes, most of their drinks are pretty much very comparable. And the reason why that matters is because if you walk in the door, they are prepared to offer you a large range of different drinks because they're similar enough to each other that they can make them all more or less with the same resources. So now, of course, they don't know in advance when you come in how many of each you might ask for. So let's say that this particular Starbucks has one person who's making espressos and lattes. Okay, so whichever one you ask for, this person will be assigned to make it. If you ask for something else, then a different person will make them. But this one individual has been assigned to the station where he or she makes espressos and lattes. And of course, you probably know espresso is just pure coffee. It's almost pure caffeine. I mean, it's just a little tiny cup of almost pure, unadulterated caffeine. I mean, if you have one of these, you'll be able to stay up all night studying, that's for sure, especially if you get a double. The latte is essentially the same thing, except it has foam milk in it. That's really the only difference. So the resources are more or less the same. They're not identical, but let's just say for our example, they're the same thing. Now, the number of espressos that we can make ultimately depends on how much time do we need to make the drinks and how many beans do we need, or in the case of the latte, how much milk. So what we're going to do is assume that within a given hour, let's say, there's a maximum amount of each that we can make. Okay, so what this chart is, or graph is attempting to show you, is this chart right here, where we have all these different possibilities. If, for example, nobody asked for lattes this evening, we can potentially make up to 28 espressos with our time and our resources. Or it's possible to make 26 espressos with 5 lattes. Also, we could do 23 espressos with 10 lattes. And you can see as we go down this list, we're lowering the number of espressos and we're raising the number of lattes until we get to the bottom, when if for some reason nobody asked for espressos, we could potentially make 30 lattes. And all of these, the key to the whole thing is all of these are made with the same resources. So the company, Starbucks, doesn't care which one we ask for. They're capable of doing all of these with the same resources. Okay, so now if you look at this curve, you notice the letters represent what we were just seeing here. So for example, let me just quickly label a few of them. Up here we have, let me see, 28 espressos with no lattes, for example. Down here at this end, we have no espressos and we have 30 lattes. At point D, for example, we have 19 and 15. And then we have everything in between. Okay, so as you move to the right, what's happening is you are producing more lattes and fewer espressos, which obviously implies is that if you move in this direction, you're doing the opposite, fewer lattes and more espressos. Okay, now we're going to make some important assumptions here. Okay, so first, hopefully we understand how this curve works. And just keep in mind, each one of these points is a different combination of espressos and lattes that we can make. Now, if you look at this graph carefully, you'll notice there's 2 other points, H and I, which we don't know what they mean just yet. So we're going to assume that points on the curve, A through G, represent points of maximum efficiency. Okay, so efficiency is maximized by producing goods and services with the fewest resources. Each point in that curve is a different point of maximum efficiency. So in other words, no matter what point we produce at, doesn't matter to us, as long as it's A, B, C, D, E, F, or G, we don't want anything different. Okay, these are all points of maximum efficiency. And that just means that none of the resources are wasted. Okay, in other words, the person who's doing this isn't standing around waiting for customers. The beans aren't getting burned. You know, they're not messing up the drinks. That's the best we can do. Any one of those is fine, but that's what we're hoping for. Now, if that's the case, then we have to ask ourselves what's going on with points H and I. Well, let's look at it this way. Suppose you're at point, if you're at point H, then we can think of this in 2 different ways. If you're at H, you could move up to B and make more espressos without sacrificing any lattes. Or alternatively, you can move across here and make more lattes without giving up any espressos. The only way that can happen is if somehow resources are being wasted. So therefore, anything inside the curve is inefficient. Okay. Anything inside, we do not want to be here because that represents all points of inefficiency. We're always going to be better off being somewhere on this curve rather than inside the curve. The points on the curve, if you notice, the only way I can get more, if I'm at B, the only way I can have more lattes by moving to C, for example, is I have to give up some of my espressos to make more lattes because I'm using my resources as efficiently as possible. Not so with H. With H, I'm goofing around. Let's say the employees are goofing around. And if they stop goofing around, they could just as easily make more espressos or more lattes without giving up the other one. Now, at the other extreme, we've got I. Now, I is a wonderful point because you notice, compared to, let's say, point C, we have both more espressos and more lattes. So why don't we move out there? Well, here's the problem. Those points outside, we simply don't have the resources to do this. So these points are said to be unattainable, meaning that they're even more efficient than what we're doing now, but we don't have those resources. Could be for a lot of reasons. It could be that the machines are just not that fast. It could be that the employees need more training. It could be that we simply don't have enough beans to do this. There's a lot of possibilities, but this is where we'd ideally like to be, but we can't reach it just yet with our existing resources. So that means that ultimately Starbucks has to basically choose between any of the points on the curve. Inside is wasteful or inefficient, outside is unattainable with the current resources, that is. Now that can change over time, by the way. Let's say the company buys faster machinery, or what if the employees get more training? Or what if we have more beans available to us? There's a lot of reasons why we could eventually move out here, but right now, at this point in time, that's not going to happen. Now, this curve can work for any two goods, as long as they're similar enough to each other. You want to make sure that they make sense. You don't put, for example, espressos and cars because they have nothing to do with each other. Okay. So this is really meant to be for goods that are similar to each other enough that we can produce one or the other with the same resources, more or less. Okay, now, here's the whole point of this chapter is that on this curve, remember I said before, in order to move from one point to the next, assuming we're on the efficient portion of the curve, in order to get more of one good, we have to give up some of the other good. Okay, in other words, having more espressos having more lattes requires us to give up some of our espressos. Okay, we can't make both espressos and lattes with the same beans or with the same time. Okay, so that means there's always a sacrifice. And so we want to quantify that sacrifice. And here's a concept that we've already been introduced to. That would be opportunity cost. So remember what this means. This is the value of the best alternative choice that must be sacrificed. Okay, in other words, when we make a choice to be at one of these points, we're giving up something else. Okay, no matter which point we're on, like if we're a B, we're giving up the opportunity to make more lattes in order to have a lot of espressos. So opportunity cost here is defined in terms of how much of one good are we giving up to have more of the other. All right. Now we know that opportunity cost can be expressed in a lot of different ways. We saw the example of college students are giving up the opportunity to work full time and earn a salary. Here we're just focused on output of goods and services. So the question is, how do we calculate the opportunity cost? Well, what I would like to point out to you is that no matter what we're doing, we're always going to have a ratio. Whatever we're looking at, in the numerator, we'll have the sacrificed good, and down here we'll have the gained good. You'll see what I mean when we do some examples. But always remember, the sacrifice goes in the numerator. For any example we might do. Okay, now we're going to do some actual examples. We're going to move along this curve and calculate some opportunity costs. Let's say we're at D. Okay, now I know it's kind of small there, but D. In order to go down to E, now remember, espressos are on the top, lattes are across the horizontal axis. As I go from D to E, I'm making more lattes and I'm giving up espressos. So what I've shown here is this is D, 19 and 15. And down here at E, we now have 14 espressos and 20 lattes. So I think it should be pretty clear that in order to gain 5 more lattes, which I have shown right here, we had to give up 5 espressos, okay? How can you tell? Because lattes went up by 5 and espressos went down by 5. So how do we calculate the opportunity cost? So what happens here is that this is the opportunity cost of producing more lattes. So like I said, the sacrifice goes in the numerator, the gain goes in the denominator. So to go from this point to this point, remember, we lost 5 espressos, but we also picked up 5 lattes. So along this region of the curve, each extra latte requires us to sacrifice 1 more espresso. So this is what we're aiming for right here. Now, it's not always 1. Okay, you're going to see in a minute that that number can be very different. And here's an interesting point. Because this is a curve, that number will change as we move along the curve. The opportunity cost will change as we move from one point to the next. Why is that? Well, think about this. You might remember really quickly. I'm just going to review this with you for 1 second. In the XY coordinate system, suppose you have a curve and we're interested in calculating the slope. Let's say at this point, the slope of the curve of this function at that point equals the slope of this tangent line. So if I'm looking at lattes and espressos, the slope of this curve at a given point is the change in espressos over the change in lattes. So you know what this means? The opportunity cost of making more lattes is the slope of the production possibilities frontier at that point. So that means that here, the slope is approximately equal to 1. Okay. Okay. So I just wanted to point that out. You don't have to know that for the test or anything. I just wanted you to be aware that the opportunity costs are actually nothing but slopes. And by looking at this curve, you can see the slope starts out very flat. In fact, let me sneak that in here. Up here, the slope is quite flat. And then no, I'm not drawing it that well, but in fact, I'm not drawing it well at all, am I? Hold on, let me see if I can do better than that. Well, all right, you get the idea. And I guess engineering drawing is not my thing. So yeah, the idea is that as we move in this direction, as X in, well, all right, let's keep it with the example of lattes and espressos. So as L increases, the slope, or let's put it this way, the curve gets steeper. The slope increases, or at least it becomes more negative. In other words, the magnitude increases. Therefore, the opportunity cost is increasing. Okay. In other words, the slopes are negative. Technically going from, let's say this is -2, -3 to -4. Technically, -4 is a smaller number than -3, but if you're only looking at the magnitudes, the curve is getting steeper, and so the opportunity costs are going up. Okay, so in other words, the more lattes we want, the more espressos we have to give up. So the more lattes we produce, the more espressos we must sacrifice. Okay. So I just want to mention that as we go along. So then the rest is just calculating the actual values. Okay. So what about, no, all right, I think I've got it down here somewhere. More specific examples. Let's jump, see, we've already done D to E. Let's see if we can find E to F. Okay. No, it looks like I don't have that as a separate example. I'll tell you what, let's look at A. A is 28 espressos and 0 lattes. B is 26 espressos and 5 lattes. So what would be the opportunity cost of making more lattes? Well, we're losing two espressos, and we're gaining 5 lattes. So therefore, the opportunity cost of each additional latte is 0.4 espressos. Okay, so that's what matters. Remember, think of it as delta E over delta L. 2/5, or it's actually negative, but we can ignore the negative for now. No, maybe we shouldn't. We want to be correct. But you know, normally we think of the opportunity cost not as a negative number. We can think of it as simply 0.4. You can ignore the negative sign. Okay. Then how about moving from B to C? So here we have 26 espressos, 5 lattes. Then here we have 23 espressos, and 10 lattes. So delta E is -3 over +5. So we say that the opportunity cost is 0.6 espressos per latte. Okay, so now already you might have noticed something interesting here. When we went from A to B, the opportunity cost was 0.4. When we went from B to C, the opportunity cost jumped up to 0.6. Okay, so if I go from C to D, you can probably imagine what's going to happen. Here we have 23 espressos, 10 lattes, and then down here at D, we have 19 espressos and 15 lattes. So delta E is -4. Delta L is 5. So look what happened. It went up again to 0.8. And if we keep going down the curve, those numbers will keep going up. So I've gathered all the results into one nice little chart. So you can see exactly what's happening. Now, by the way, I do want to point out, this is one of the peculiar things about this book that I'm not too crazy about. In this chapter, at least, they use the word marginal and opportunity cost interchangeably. I'm not sure if I'm happy about that, but just be aware that these two mean the same thing. It basically means the change in one variable with respect to a small change in another variable. Okay, oh, hold on. All right. Okay, sorry. So anyway, those are the numbers we've been working on. And if you continue to work on those calculations, you'll see this is exactly what they look like. Okay, now, all of that showed us how to calculate the opportunity cost of making more lattes. Okay, so that's what this shows me. What if I wanted to do the opposite? Instead of starting in the upper left-hand corner and making more lattes, what if I start in the bottom right-hand corner and try to make more espressos? Okay, so for example, now I want to go from, let's say here, point G, where I had no espressos and 30 lattes. And then I want to move up to F, where I have 8 and 25. So I'm going now in this direction. And so what I'm looking for is the opportunity cost of espresso, because I'm making more espresso. How much latte do I give up? It's going to be delta L now over delta E. So this one will be, I lost 5 lattes and I picked up 8 espressos. So you can think of the opportunity cost, you can ignore the sign, as about 0.2625. Okay. Now, if I continue to move up the curve, E is 14 espressos and 20 lattes. So now delta L over delta E, we lost another 5 lattes, but we gained this time 6 espressos. So that's 5/6, which is approximately 0.867. Running out of space here. Let me just double check that one on my calculator. 5/6. Oops. is 833. Okay. Okay, so approximately negative 833. Now remember, forget the signs. All right, let's do one more. Let's go up to D. We don't need to do every single one of them. I think you're getting the idea. Here we have 19 espressos and 15 lattes. And so we're going to gain, or actually we're going to lose 5 lattes again. But this time we're gaining 5 espressos. So if you notice the pattern here, from 0.625 to 0.833 to 1. All right, what the heck? Let's do one more. C, 22 espressos. Sorry, 23. I'm looking at the wrong thing. And 10 lattes. So now delta L over delta E is negative 5 over 4. Ooh, it's getting bigger and bigger. All right, so I've once again listed all of the opportunity costs in a chart. But remember, we're moving in this direction now. So these numbers now represent the inverse of the slope of this curve. That's why they're getting bigger. These are now inverses of the slope. The actual slope is delta E over delta L. Here we're actually taking the inverse of that, and therefore it gets bigger as we make more and more espresso. Very good. Now let's look at the chart and you'll see what I mean. So remember, we're starting at the bottom and we're moving up. And again, this is the same thing as opportunity cost. I don't know why the book insists on doing this. And either way, what you're seeing here is that as more of one good is being produced, the opportunity cost of the other good is increasing. Okay. Now, what I want to point out here, though, is that this will always be the case if the PPF, production possibilities frontier, is curved. Okay. Now, just a quick side note here. When you have a production possibilities frontier like this, there's realistically only 2 shapes it can have. It can look something like this, which you might recall from high school math is called concave. It can't be convex, okay? That would imply that less resources are needed to make more units of the good. So convex is out. The other possibility, which we'll see later, is that it's simply a straight line. That is a strong possibility too. Okay, this is a possibility as well. Now, one of the interesting consequences of a linear production possibilities frontier is this. Well, first, concave PPF is that opportunity costs continually increase as more of a good is produced. One of the consequences, and we'll see an example of this later on, of a linear PPF is that opportunity costs are constant. They never change. Because as you know, this is because the slope of a line is constant. Okay, so there's, remember, the PPF itself is simply a slope of some kind. Therefore, if I have a straight line, the opportunity costs have to be constant. It doesn't matter how much of the product I make, it's always the same. Like it could be 3, for example. Okay, so that's one of the interesting things. Most of the time in the real world, we find that production possibilities frontiers are concave, but occasionally they can be linear. Let me show you a good example of a linear one. I think you'll like this one. Now, by the way, I do want to mention one thing here. Unlike the XY coordinate system, where the vertical axis is the dependent variable and the horizontal axis is the independent variable, here there's no necessary relationship between the two. They're just two goods. So here, the reason why I'm mentioning that is because what I'm going to do here is take time. And I'm going to say on the vertical axis, we have sleep. And down here, I have everything else. Now, why am I doing this? Because, and by the way, the intercepts are 24 and 24, which means that you could spend 24 hours sleeping, 24 hours doing everything else, and anything in between. For example, you could have 8 and 16. But you could also have 6 and 18. And if I move between these 2 points, the change in sleep over the change in everything else is -2/2, which is -1. And if I come up here and do 10 and 14, and let's say I move back in this direction, it doesn't matter. Delta S over delta E, whoops, is still, actually in this case, it's +2 over -2 if I go in that direction. But the point of it is that it's always 1. In other words, if I want 1 more hour of activity, I have to give up 1 more hour of sleep. And that never changes because there's only 24 hours in a day. So there's no way you can find a way to sleep less and do everything else. You're not gaining more and more as you sleep less. Let's put it that way. It's always 1-to-1. So this is a good example of a linear production possibilities frontier, because there's nothing you can do about this. Sleeping and everything else, it's always a direct trade-off of 1-to-1. All right, I thought that was kind of a nice example because everybody faces this one. All right, if you found a way to get more than 24 hours in your day, I'd like to hear about it. You should patent that and make yourself insanely rich. That would be one product that would sell more than anything ever in history, a product that gives you more time. Man, I'd like to see that. The old buy some time machine. Wow. Ooh, boy, whoever did that would be rich. Okay, now it turns out, interestingly enough, this production possibility frontier is actually heavily used in a branch of economics called international trade. Now, that's something that you might take after, if you're an economics major, you might actually take a course like that where you just focus all of your attention on international affairs. And so what often happens is in international trade, we use these production possibilities frontiers to explain how and why countries trade with each other. Okay, so in other words, what's happening is that instead of having Starbucks produce espresso and lattes, you might have the United States is making, let's say, cars and agricultural commodities like wheat or something, and they're trying to make a decision how much of their resources to allocate to each good. In other words, the U.S. has to decide, well, should we make more cars or should we make more wheat? Well, there's a lot of possibilities that go into that, but it ultimately comes down to how much can we sell our products for and how much demand is there for our products. So entire countries can be analyzed using these curves. And usually the whole idea here is that we're trying to figure out which countries have an edge on certain goods and should probably focus on those, and which countries should probably give up other goods. Just as a quick example, most of the coffee that we drink is not grown in the United States. We can grow coffee in Hawaii, but that's pretty much it. The rest of the country isn't really that well suited for coffee. If we tried to grow our own, we could probably do it, but it would be horribly inefficient. So what do? We buy it from other countries. Okay. On the other hand, there are a lot of countries in the world who do not have the capabilities of producing, let's say, a commercial aircraft, like Boeing, for example. So what do? They don't try to make their own. They buy them from Boeing. And so with the Production Possibilities Frontier, we can explain a very important concept in international trade. It's called the law of comparative advantage. And essentially, this is one of the most important explanations or theories as to why countries trade with each other. Okay, so let me just briefly introduce this concept to you. A country is said to have a comparative advantage in the production of a good if it can produce that good with fewer opportunity costs than other countries. Okay. In other words, if you are able to produce a product with the lowest possible opportunity cost, then you are the one who has the comparative advantage. So let me throw out some examples for you. Let's say that Mexico is able to produce avocados extremely efficiently. Okay, there's something about their soil and their climate. The US, on the other hand, is extremely efficient at growing, let's say, cranberries. Why? Because the soil is right, the temperature, and all the rest. Therefore, Mexico has a comparative advantage in the production of avocados, while the US has a comparative advantage in the production of cranberries. So what would it make sense for these countries to do? Under these circumstances, should the US try to grow both? Should Mexico try to grow both? Good question. So it turns out, and we can prove it with opportunity cost, that output of both goods will increase if the US specializes in the production of cranberries. Mexico specializes in the production of avocados, and the countries trade their surplus for the good in which they do not have a comparative advantage. In other words, the US doesn't try to grow its own avocados. Instead, we grow more cranberries than we need, and we trade the surplus to Mexico for the avocados that they produce, but they don't need. In other words, they both just make the one thing. They get very good at it. They trade with each other, and it turns out that both countries can have more of both goods by doing it this way. Now, this makes sense if you think about it in terms of like not even just countries. What about individuals? How does this work with individuals? Well, if you're a farmer, you farm, you grow crops, and you sell them, and you use the money to buy things that you can't make yourself, like cars, for example. Or even to put it at an even more basic level, as an individual, you probably don't have your own garden in the backyard where you would grow your own vegetables. Well, maybe you do, but let's say you don't. Why might you not want to bother growing your own vegetables? What would be the thing that holds you back? What do you think? Would that make sense to grow your own vegetables? Well, especially if you live in the city or in a city. No, because the time that it would take you to grow a halfway decent crop of carrots, you could be using that time to do something much more valuable. Yes, exactly. You don't have the time, skill, or resources. You're just theoretically, yes. I mean, anyone can plant crops in their backyard. But you know, if you've ever tried it, it's a lot of work and it doesn't always work out so well. And then sometimes if you do have a nice crop, then deer eat them anyway. You know, it's like, let's just say you're better off just working more hours at your job or whatever you're doing and then buying the crops, I mean, the vegetables you need at the supermarket because they came from farmers who know what they're doing. So therefore, as an individual, you focus on the things you're good at. And then you use your extra cash to buy the things that you're not so good at. Now, like, for example, do you make your own clothes? Of course not. That would be absurd unless you happen to have a particular talent for it. So what do? You buy at the store. You do anything you're not good at, you just don't do it at all. Trade by using cash, you're in effect trading your skills for somebody else's skills. So therefore, as individuals, we do this all the time. Focus on our area of comparative advantage. We find the thing that we're the best at, and we just do that all the time and let other people produce food that we can buy and clothes that we can buy and cars that we can buy. And the same thing is true with countries. In fact, you may, if you look in your closet and look at the little tags on all your clothes, you're not likely to find anything that was made in the US. The US doesn't make a lot of clothes. Why not? Well, because clothes require a fair amount of labor, physical labor as opposed to machinery. And this is not an area that we're particularly good at, not because Americans can't make clothes, but because labor is relatively expensive in the United States. So in other words, if you have people making clothes in the US, those same people might have been able to make something even more valuable, like working in a factory that makes aircraft. So it would not be a good use of our resources. So instead, we buy all of our clothes from countries like India and China, where labor is very cheap. Okay, and then they in turn buy our high-tech products that they are not able to make. Okay, in fact, there's one area where the US has a huge comparative advantage. Graduate schools, I don't know if you are even aware of this, but when you're done with college, you can go on to a more advanced degree, a master's degree, for example, or a doctorate. And when you're at that level, that's referred to as graduate school. And it turns out that countries like China and India are growing so fast that they don't have enough graduate schools for their own students. So what do? Rather than making their own, which takes a long time, they pay the United States. In other words, they send their students to the United States and pay those schools directly so that, you know, like if you're Chinese, your government might say, go to the United States and study at Harvard, let's say. We don't have enough schools for you, so you go over there. And so the government is taking advantage of our particular skills in producing education. So this is how trade works, and trade benefits everybody because ultimately more output is being produced. But we do use production possibilities curves to illustrate this, and we'll see this in a few minutes. But first, let's take a fun detour. Now, this will be especially important for you if you do decide to major in economics. We want to understand where the international trade theory has come from. So we're going to look at three basic types of ideas that prevailed at different points in history. So mercantilism is basically from the 15th to the 18th centuries. This is the time when the Spanish and the Portuguese and the English and the French and the Dutch are colonizing South America and other parts of the world. And they see their job as to try to take advantage of each other. And trade, as far as they're concerned, is another weapon of warfare. So what they would try to do in mercantilism is they will try to export goods to other countries, and then instead of buying those countries' products, they'll expect to be paid in gold and silver. And the gold and silver can then be used to make bigger armies and navies and get more colonies. So in these days, trade is seen as simply a way of taking advantage of your neighbors and giving you a military edge over them. So the idea here, yeah, I mean, it's just straight ahead of foreign policy. Then along comes Adam Smith. Remember this name if you can. This is the person who really started economics as a discipline. He wrote this massively famous book in 1776 called The Wealth of Nations, in which he introduced a lot of what we now know to be modern economics. And among the many other things he wrote about was why mercantilism was a terrible idea. He basically explained that countries will not trade with each other unless they all feel that they're benefiting from it. Okay, in other words, if you think your trading partner is trying to take advantage of you, you're not going to trade with them. It's just that simple. So trade has to be mutually beneficial to take place. Like I said, with the United States trading cranberries to Mexico for avocados, because cranberries require relatively cold weather, which you will not find in Mexico, and avocados require hot weather, which you're not going to find in the United States. So they trade with each other, and everybody has more avocados and more cranberries. So now this is a quote from the book. And basically what he's saying here is that if a foreign country can supply us with a commodity cheaper than we can make it ourselves, then we should buy it from them with some part of the produce of our own industry, employed in a way in which we have some advantage. In other words, let the US trade Boeing 747s to the rest of the world and buy clothes and agricultural products like coffee that we don't grow very well ourselves. And so this was a pretty revolutionary idea. Remember, after 300 years of mercantilism, he's really bucking the tide here. He's saying, listen, everyone, what's wrong with you? Trade will only happen if everybody feels that they're benefiting. Now, David Ricardo comes along about 30 years later and refines this a little bit. By the way, Smith referred to this as absolute advantage. If you ever produce a product more cheaply than other countries, then you have an absolute advantage. But David Ricardo comes along and says, no, that's not strictly speaking true. As long as one country has lower opportunity costs, they can focus on and export that good to other countries, in which case we say that country has a comparative advantage in that product. Okay, so it's essentially an extension of absolute advantage to, it's a broader principle which explains a lot of trade throughout the world. Okay, like I said, in principle, if the US was really desperate, we could grow our own coffee. It just wouldn't make any sense if we can buy it more cheaply elsewhere. So we're going to do that because it makes sense economically. All right, so this example that's about to follow is fairly involved. Now, unfortunately, I have to take off early today. I have dealings to deal with. I had my car totaled fairly recently, and I have a lot of crap to deal with. So today I have to unfortunately cut out early and attend to this. But we should have a full normal class on Friday. And in the meantime, plus this is a long example anyway. So I think what I'd like to do is start this example of comparative advantage on Friday. And we'll just go through it step by step. And when we're done, you should be able to take away how countries trade with each other based on comparative advantage and opportunity costs. Okay. So in the meantime, why don't you just read the slides and keep up with what we're doing. And if you miss something, you can watch the recording, which I'll be putting on YouTube, and I have already. And like I said, unfortunately, I have to cut out early, but we'll make up for it next time, that's for sure. And I'll see you all on Friday. Okay. Any last minute questions? Okay, great. I'll see you then. Oh, yes, Fernando?
Oh yeah, I have a quick question if you don't mind answering.
Go ahead.
So the charts that we went over earlier, that was more like emphasizing on like opportunity costs.
Yes.
Okay.
That's right. Opportunity. Actually, the whole point of this chapter is the opportunity cost, but we're seeing it at the level of one company, sorry, making two goods, and then we're going to see it at the level of two countries that are specializing in two goods. So that's what's coming up next. We're bringing it to the big picture now. Countries trading with each other, and how do they decide which country produces what, and how does that improve our well-being?
Oh, okay. Thank
Oh,
you,
it's
Professor.
interesting. Very interesting. Uh-oh, did I miss all these chats? No. Yes. Goodbye. Thank you, everyone. You're
Thank
welcome.
you, Professor, for class. Have a
Okay.
good day.
Sure. Okay, bye. And Devin?
Earlier, you said something about the marginal cost being the same as the opportunity cost.
Yes, in this chapter, this book uses that notation. I don't know if that's the best idea, but this book, and that chapter calls it marginal and opportunity cost interchangeably.
Yeah, I was confused about that.
Yeah,
earlier.
I think that's a terrible idea. I don't know. I should write to them and say, please don't do that anymore.
Because I thought opportunity cost was the best thing that you're willing to give up.
Well, in a way, it means the
cost.
same thing because it basically refers to what are you giving up to make one more unit of a good. Okay. I mean,
Yeah.
in principle, it's the same thing, but I think it's confusing the way they've done it.
So wait, is marginal benefit something what you're willing to give
Oh,
up?
benefit is different because what's happening is you're saying if I consume one more unit of this product, how much more benefit do I get?
Okay.
So the word marginal means the cost or benefit of doing something one more time.
Okay. Thank you.
And we'll get into that too. All right. Anyone else? Okay. All right. See y'all next time. Bye.